In this tutorial, you're going to learn how to graph quadratics and find their zeros. So if you're following along in your notes, we're starting a new unit. You can write the appropriate page number. So quadratic equations look like this. Their equations always have an x squared, and their graphs always have a nice soft curve. We've been working with quadratic equations for a while now, while we've been factoring polynomials. So a quadratic equation, when written in standard form, has the x squared term first, the x to the first term second, and the constant last. Now a quadratic equation has to have a variable with a power of 2. These other terms may be included or may not be included, but you have to have a term that has a variable with a power of 2. If you're looking at a quadratic graph, you'll know its shape if it looks like a parabola. So a quadratic graph can have a parabola that tilts downward, like this one here, or tilts upward, like that one there. And it's easy to tell when you have an equation like this, which way the parabola will be tilting. The coefficient, right, of x squared, which we're calling a here, can either be a positive number or a negative number. And if the coefficient of a is negative, the parabola will be facing downward. And if the coefficient of a is positive, the parabola will be facing upward. So that gives you some good common sense for when you're just initially looking at a graph or when you go to graph your own. So sometimes we say that the parabola will open down when the value of a is negative, and sometimes we'll say the parabola will open up when the value of a is positive. A quadratic equation is in standard form if these three things happen. 1, the polynomial is equal to the number 0. 2, the terms are arranged in descending order. That's with the highest variable power first and going down from there. And if the coefficient of x squared is generally positive, you know that it is in standard form. So here we have an example of a quadratic equation that is not currently written in standard form. Right? First thing, it's not equal to 0. Right? Second thing is it's not written in descending order. So the first thing you would do here is you would think in your mind, well, which term needs to be moved, right? We can use some properties of equality here to move them. And I'm going to skip this whole property of equality step where I write it twice. I'm going to skip that and just think in my mind, okay, I would prefer if this 6x were to come to the other side. Now think carefully about how I wrote my arrow. I didn't just kind of willy-nilly just draw it anywhere. I clearly indicated that I wanted to come to the other side and I wanted it to be in between these two terms. Right? So that really helps to show my understanding. Not only do I want it to switch sides, in which case it will switch signs, but I also want it to be in between these two terms. So when I go to rewrite my answer here, I would have x squared, my new term that switched sides in the middle, negative or minus 6x, and then my constant. Let's take a look at another example. 7x equals negative x squared minus 10. So first of all, it's not equal to 0. And second, my leading coefficient, right, my x squared term is negative, and we want it to be positive. So that means I'm actually going to move two terms this time. I'm going to move the x squared, and I'm going to move the minus 10. And take a look at my arrows. Right? I'm not just randomly drawing them, I'm indicating where exactly I want that term to move. Not only is it going to switch its sign when it comes to the other side, but I'm going to specifically put it in its exact location. So when I rewrite my term, it will be x squared, positive x squared, plus my existing positive 7x, and then my new plus 10 constant. Let's take a look at another one. So it's certainly not equal to 0, and it's not in descending order because all of the terms aren't on the same side. So the question is, who needs to move? Well, the third thing we always like is for our leading coefficient, right, our x squared or r squared in this case, to have a positive coefficient. So for this example, I'm going to move the 64. And when it switches sides, it switches signs. Now technically, I'm using a property of equality here. I'm skipping this step by showing it fairly on both sides because I think you have an understanding of how that property works. So on your paper, you could show just this final answer. All right, let's take a look at this last one here. Write the quadratic equation in standard form. Well, it wouldn't have any parentheses. So first I'm going to distribute this x, and then once I get my new terms, I'm going to move this 15 to make it equal to 0. And there's our final answer. All right, I think you're ready to give it a try. Pause the video, try manipulating these 4 equations so that they're all written in standard form. Okay, are you ready to check your answers? How did you do? Great. Let's move on to the second part of the lesson. A solution to a quadratic equation is the value of x that will make the equation equal to 0. So if y is equal to 0, what would x be? Now we've been solving sentences like this by factoring. Say I have something like this. Right? So I know this is a quadratic because it has an x to the power of 2. And I know that it would be shaped like a parabola because it's quadratic. Another thing we learned today is I know that that parabola will be facing upwards, right? Because it has a positive coefficient here in the A position, right? Positive coefficient. And now what we're going to concentrate on is what are these two values here? What are the solutions? What are the value of x if y is 0? Right? That's what we're concentrating on today. So when the y value is 0, then the point we're looking for lies on the x-axis, and that's called an x-intercept. So today I want to introduce you to the 4 terms for the same item that we're talking about here. So where this parabola crosses the x-axis is called the x-intercept. That's pretty obvious of a definition. These x-intercepts are also known as the solutions. They're also called zeros because their values will always have a 0 in the y position. And in some cases, as we move along, we might even refer to it as a root. Now, we won't be using that term today because we won't be solving using square roots, but that is another term we can use. So a solution, a 0, an x-intercept, and a root are all synonyms for the same point along this parabola. So this particular parabola has 2 solutions, or 2 zeros, or 2 x-intercepts, or 2 roots. So I'm probably never going to use this phrase, only because it basically gives it away. It tells you exactly where to look. So I'm probably only going to refer to them by these 3 words. Now when you're looking at a parabola, how can you determine how many solutions it has? Right? So if you're looking at its graph, or what I just called it, a parabola, how can you determine how many solutions the quadratic equation has? So there are only 3 things that can happen. Your parabola can be in some quadrant, and it doesn't matter which one, where it actually never crosses the x-axis. And if that's the case, we're going to call it today no solutions. Now technically it has some imaginary solutions, but you'll get into that later. So if it does not cross the x-axis, we're just going to say it has no solutions. If it crosses the x-axis at exactly 1 point, such as this one here, we're going to say that it has 1 solution. Now sometimes we call it a double solution because sometimes when you factor something, you get a duplicate factor, right? If we factored something and these were our factors, then we would have solutions of positive 2 and positive 2. And so that's a repeat solution, but it's only 1 point. And then the last is the double solution, right? 2 solutions here Oh, sorry, not a double solution. A double solution is when you have a repeat. Two solutions is when you have two totally separate answers, like 1 and 3. So let's take a look at these here, right? If I were to ask you to find the exact solution of each quadratic, which is what we were just looking at, how would you list them? So for the first one, there's no solution. You can write it in English, no solution. You can write it in math. That's that 0 with the slash through it, right? It's actually not the number 0. It's the null set. And if you want to be fancy, you can put those braces around it to say that there are absolutely no solutions to this quadratic function. The second one has a single point. It is the point 2, 0. But a solution is just the x value. So we're going to label it like this. And since there are two solutions here, we're going to put a comma between them. So that's pretty simple. You can look at the parabola, see where it crosses the x-axis, and that x-intercept will be your solution, or your zeros. Now sometimes when you're looking at a graph, it's kind of hard to tell. Now we can estimate what we think these to be, but we can't technically be sure. Is it really 3.5? Maybe it's 3.45. Maybe it's 3.498762, right? We don't exactly know. So in cases like this, we would use technology to help us. You can find the solutions to a quadratic equation by using your graphing calculator. So here's a pretty busy looking example of how it would look on your calculator. Let me show you. So if you have a quadratic equation like y equals x squared plus 2x minus 3, and you have a graphing calculator, let me open mine up here and turn it on. If I were to type this equation into my y equals button, like this, x squared plus 2x minus 3. Right, whoops. It's kind of sticking out of the... I can't get it to come into the screen totally. Alright, here we go. Alright, let me try my best here. Alright, if I were to look at this graph, I can see that as the parabola is drawing, that it crosses here at -3 and it crosses there at +1. So I picked some really good solutions here for you because we can see them very clearly. But let's say we couldn't really tell. Well, we would use this sequence here to actually trace or find those particular zeros or solutions. So this is how you would do it. You would press second, and then you would press the trace button, right? And above the trace button is the calc feature. That's what we're activating. We want to calculate the zeros. So do you see that in the menu there? So it doesn't say solutions, it says zeros, because we're looking for points that have zeros into the y values. Now, the second thing you have to be aware of is that there are two solutions, right? So we need to do this twice. And the calculator requires that you do something called show it the left bound or be left of the actual zero, and then be to the right of the actual zero. And that's where the calculator is going to focus. So it needs you to kind of set some boundaries for it. A left side boundary and a right side boundary. And then look, as we move along the parabola, on the other side, the left boundary would be down and the right boundary would be up. Does that make sense? So as I'm traveling here, this is left of the solution and this is right of the solution. But as I come back up the parabola, this is left of the solution and that is right of the solution. Now you can't find both roots at the same time. You can't find both solutions at the same time. You have to do one at a time. So when we choose second, trace, and we're in this menu, and we select the number 2, we need to use our cursor arrows here. Do you see it blinking? I'm going to move it, right, using my left arrow key. I'm going to click, 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 click until I get left of that point. Now I can be really far from that point, or I can be just slightly above that point, but I don't want to be too far away from it. Alright, so that's really close. I'm going to go up a little bit higher. Okay, see that there? I am currently left of that 0 point. And once I'm where I want it to be, I press enter. You see that line? I'm starting to give the calculator a zone where I want it to look. So now I have to move my arrow down to the right, right, right. See, it's asking me, are you to the right of it? Are you right bound? And now I'm going to press enter. You see these two lines and these two arrows up here? That's the calculator saying, hey, I'm going to look in between these two imaginary lines to find your 0. And then now it's asking me, do you want me to make a guess? So I'm going to press enter. Yes, yes, I would. And there is my solution point, -3 and 0. Right? We were able to see that here in the drawing, -3, 0. Now let's do the same thing to find this right solution. So I'm going to press second, trace. I'm going to choose number 2. And now I need to be closer to the other point. So I'm going to press my arrow key here. And remember, I need to be left of it. So on this side, left is going to be below it. So let's see, I'm going to click, click, click. I'm going to keep moving my arrow, my little blinking cursor, right? Until I am kind of close, but not necessarily right on top of it. That's pretty good. So that is my left bound. I need to press enter, right? Are you left of the solution point? Yes. Now I need to move my cursor so that I'm above it or to the right. Press enter. And now I'm ready for it to make a guess. And there's my other 0. So that's how you use the calculator to help you find the solutions from your graph. Now, when they're integers, it's pretty easy to see with your eyeballs, but sometimes they're in between. So you need to use this feature to get that rational number. Now, if you don't have your graphing calculator at home with you today, but you do have a phone, you can download one of these apps, right? If you have an iPhone, you might want to try the Calculate 84 app, which will help you to graph these. If you have an Android phone, maybe you want to download the Wabbit EMU, which is what I've been using here, right? It's this one here. And if you don't want to download anything on your phone, you can always use the Desmos app on the internet, right? So the Desmos app looks like this, right? Desmos.com. And I'm going to shrink it up here a little bit so that it fits in my screen. And I'm going to show you how to graph it here. So if you're using the internet as your graphing calculator at desmos.com, right? You'll see this when you sign on. The main website will say Explore Math, and you just click Start Graphing, and it will open the screen for you. Now to type in some powers and things like that, you need to open the keyboard here in the bottom left. So I'm going to type what our function was again, and our function was, let me go back, our function was x squared plus 2x minus 3. So I'm going to type x, I'm going to raise it with this key here, x squared plus 2x, and then I think it was minus 3. All right, now on the Desmos app, let me get this keyboard out of the way for a minute. On the Desmos app, you can simply take your mouse and you can hover over the root, or the 0 here, right? You can hover right over it, and when you see when I move the mouse, it shows it to me right there. I can even click on it. So I want you to give one of these features a try, either the Desmos online app, your graphing calculator that you have in your hand at home, or one of these other apps on your phones if you want to use that. Remember, you can't use a phone on the Regents, so I would prefer that you're using your own graphing calculator to get that experience here. Now, if you're using the app on your phone, you'll notice that when I did the same features here, when I pressed second calc and I chose number 2, that the zeros are listed down here and something else is listed above it. You see the circle here? That's a point, and that's what's listed first. But you see that square? That's my actual 0, and that's what's listed here underneath. So it's a little more confusing than what I showed you using the actual TI-84 calculator, right? So I want you to know that there are some differences. And again, you can't use your phone on the regions, so I don't necessarily want you practicing with this feature, but if you don't have a calculator at home, this is better than nothing. All right, let's see if you can try a few of these. I would like for you to use some technology, and I would like for you to graph these and find the solutions graphically as opposed to by factoring, because I know we're good at that already. So I really want you to give technology a try here. I want you to write everything in standard form, put it in your graphing calculator or your Desmos.com, and check to see if you can find those solutions. So pause this video now and give it a try. Alright, are you ready to check some of your answers? Let's see how you did. Hopefully you wrote everything in standard form, because you can't put it into the y equals button unless you have a 0 here, right? So this is technically the y. All right, how did you do? If you have a chance, I'd like you to try graphing some things if you have some graph paper at home, by graphing them yourself, by looking at the table of points if you are able to, right? If you are able to use your graphing calculator to open the table of points, then you can write some of these points down and you can try graphing them on your own graph paper. And if you don't have graph paper right now, that's okay. When we come back together at school, I'll give you some. All right, if you think you got the hang of it, I'd like for you to write this in standard form and find the zeros of this quadratic equation by graphing using some technology.